This video will show you how to process simulations when you're looking for internal defects. So I've got a simulation here of AFI, a zeolite framework, and I've coloured it with layer colouring. And if I use the depth buffers from within the visualiser, I can cut off the front face of the crystal, and we can see the internal defects within the crystal structure. Also see it with points. But whenever we're looking at internal defects, we need to run a second sweep for neighbours within CrystalGrower, as the first sweep may not be sensitive enough to pick up all the things that should be marked as internal defects. But this process does slow the simulation down slightly, so by default it's disabled. So going back to my CrystalGrower user interface, I've loaded the simulation which gave us the result we were just showing on the screen. And it's set to do some layer colouring using the same file that I used. But I want to tell it to do a second sweep for internal defects. So if I go to Advanced Options, and this option here, Advanced, how many checking sweeps? 1 is normal, 2 to clear internal defects. So if I click number 2 here, save and close window, it's now got all the same settings I used to run my first simulation, but it's going to do an additional sweep for defects. So I'll just run this simulation now. So now that our simulation's completed, we can visualize this in Ovito, and we can look at some methods for visualizing internal defects. So you have to make sure that your third column is marked as particle type. That's your layer coloring. And if we then go over to particle types, we've got quite a few different types here that are being shown. So types 1 to 4 are the normal layers, so the things that have been identified as layers. You need to make sure you've got your facets file set up correctly to identify the surface of the crystal. And you want to try and get it as good as you possibly can, so identifying just the surface and not eating too much into the crystal. Then we've got our types greater than 100, so type 101 to 104 here. These are things that haven't been identified as part of a surface layer, but they're not fully grown units. So these could be our internal defects. And they are separated by species type. So in the AFI crystal structure, there are 4 tile types. So type 101 are our internal defects of tile type 1. 102 is tile type 2, 103 is tile type 3, 104 is tile type 4. Then we've got our types greater than 1000. So these are a little bit complicated, but what they denote is that this species has a vacancy next to it. So in the visualizer and in Ovito, species that are fully coordinated are not shown. So if a species was missing next to a species, it could be that it's fully grown, or it could be that it's a vacancy. What these type 1001 to 1004 show is that there is a vacancy neighbouring one of these units. So even though it could be fully condensated, it does have something missing next to it. And they're separated by type, just like the 100s were. So 1001 is tile type 1, 1002 is tile type 2, 3 and 4, and so on. So let's try and see what these internal defects look like. So the first thing to do is to make the surface species very small. So I'll make the radii small, 0.01. And I'll do that for types 1 to 4. And now we've got quite a lot of species on the inside being shown there. Then I'll do the same to the 1000s, so I'll make those very small as well, as they're indirect defects, not direct ones. So we've only got then the 100s being displayed. So still quite busy, there's a lot of stuff going on there. So the next thing we can do is add a modification to our scene in Ovito, and we can add a slice. So a slice here, we can choose which direction we want it to slice through the crystal. So I'm looking down the y-axis right now, so I'll set this to 0, 1, 0. And it's reversed, so if I spin around. And you can actually start to see something here. So we've got a nice hourglass feature in the middle here. This is shown quite clearly by our purple and blue species in the system. So let's try turning off the green and yellow species. So that will be our types 104 and 102. You can still see some purple and blues on the sides here, but the density of the defects in the hourglass zones are quite strong. You can make these just a little bit smaller to try and make it a bit clearer, because they're overlapping a little bit. Let's reduce these down to 0.2. So that's a bit too much. Maybe bump them back up to about 1. Or maybe 0.8. So we can even just look at one species at a time as well. So I could just show only the blue tiles by reducing the purple down to 0.01. And then we've just got our blue species there. And as you rotate the crystal, you can really see this hourglass feature down the bottom here. So now let's try looking at the indirect defects. So if we change that to 0.01 and scroll down to our thousands, let's try looking at that species. So let's change that to 0.8 as well. And that's almost the opposite of the type 101. You can see that these are more clustered on the edges than in the hourglass zone here. If we look at one of the other tile types, so maybe type 2, which didn't really show much for an hourglass, you can see those are quite concentrated on the sides as well. It almost looks like an opposite hourglass, so it's running in the X direction instead of in the Y, like the other example. So I've switched over to the CrystalGrower visualizer to show the options that are available here as well. So I'm going to load that structure that had the second sweep for internal defects. And you can see it's retained the options that I had at the beginning of the video. So I've shifted the depth buffers to cut off the front of the crystal, similar to how the slice worked in Ovito. So if I show the overlay and display the full overlay, I can show my depth buffer positions. So I'm going to change the point so this reacts quite quickly, and I'm going to move the back buffer position as well to try and get a slice similar to Ovito. So we've got our slice now, but the benefit of the CrystalGrower visualizer is that everything is displayed as the actual natural tiles that make up the structures. So the display options are slightly different in the visualizer. Instead of having types 100 and types 1000, you've got layers 5 and 6. So if I keep scrolling through the visualizer, I'll just add the background to make this clearer. Up to layer 4, that's the surface. If I now press space and select the center, you've got layers 5. So layer 5 would be your types 100 in Ovito. And then layer 6 are your types 1000. So you can switch these on and off. So if I just switch off the internal defects for layer 6, it's gotten rid of all those red tiles. You can also display tiles as just their type, but this will not differentiate between the layer types of these tiles. So it's showing all of tiles type 1, 2, 3, and 4. But you can still get some interesting structures here by switching all the tiles off and looking at them one at a time. So you can see the hourglass behavior between the tiles. So tile type 1 shows it very clearly. Tile type 2 shows the hourglass in the X direction. Tile type 3 in the Y direction again. Tile type 4, a weak hourglass in the X direction as well. So I hope that's given you some routes of how to display internal defects within your crystal structure. AFI is an isolated example. I just picked this one because it shows nice hourglass behavior. But these visualization methods work on any crystal structure.